Welcome to Engineering Python. This is a Python programming course for engineers. In this video, I will talk about how to use Pandas for data analysis. Pandas is a Python library for data analysis. It is usually used together with NumPy. Before we start, we need to import NumPy as MP and import Pandas as PD. First, let's create a data time index using the date range function in PD. The date range starts from January 1st, 2018, 30 minutes and 40 seconds past 8 p.m. The period is 10. The frequency or step is 2 seconds. This is the output. It starts from 40th second, then this is 42nd, 44th, and so on. There are a total of 10 data time strings. The last one is 58th second. In this example, we create a data time index with 4 days because the period is 4 and the frequency is 1 day. Some other commonly used frequency letters are listed here. A means yearly or annually, M means monthly, W means weekly, and so on. Now we create a data frame with the data time index and these column names using the data frame function. A data frame is a 2D labeled data structure with columns of potentially different types. We use NumPy random function to generate 4-row and 3-column random distributed data from the standard normal distribution. The index is the data time index we just created. It contains 4 dates. We give each column a name. The first column is a string A, the second is B, and the third is C. They are enclosed in this list and assigned to columns. This is the first data frame we created. The top row is the column names. The leftmost column is the data time index. This part contains the 4-row by 3-column random numbers. We can also give the index column a name using this statement. This is the new data frame. We can create a data frame using a dictionary of 1 or more Panda series. In this dictionary, 1 and 2 are the keys. They are paired with 2 series. Each series will just create a single column data. The first series contains 2 numbers, 1 and 2. The indexes are A and B. The second series contains 3 strings, T1, T2, and T3. The indexes are A, B, and C. We create data frame 2 by merging these 2 series in the dictionary together. This data frame has 3 rows and 2 columns. This NaN means not a number or empty. This is because the first series originally has only 2 rows. When it's expanded to 3 rows, this cell will be empty. We can see from this example that a Pandas data frame can contain heterogeneous data. We have numbers, an empty cell, and strings all in the same data frame. This is very different from a NumPy ND array because it can contain homogeneous data only. That means if one element is a number, all other elements must be numbers as well. If one element is a string, all other elements must be strings as well. After the data frame is defined, we can just type in its name to view its content. If we only want to see the top 2 rows, we can use the head function with an argument 2. The output contains only the data of January 1st and 2nd. This is useful when we are dealing with large data sets and we don't want to see the entire data frame. Similarly, we can use the tail function with an argument 3 to view the bottom 3 rows. The output contains only the data of January 2nd, 3rd, and 4th. The index attribute stores all the data frame indexes in the leftmost column. In this case, it's a data time index from January 1st to January 4th. The columns attribute stores all the column names in the top row. In this case, it's A, B, and C. The values attribute stores the actual value. In this case, it's the fourth row by 3-column random numbers. The describe function shows the basic statistics of the data frame. For example, count means there are 4 numbers in column A. The mean of these 4 numbers, the standard deviation, the minimum value, the 25th percentile, the 50th percentile, the 75th percentile, the maximum value. The numbers for columns B and C can be explained similarly. We can use df.T to show the transpose of the data frame. This is the output. The rows are changed to the columns and the columns are changed to the rows. Transposing is not done in place, so the original data frame is not changed. The sort index function will sort the data frame by index. When access equals 0 and ascending is false, we are sorting by the data time in descending order. So January 4th data is now on top and January 1st data is now at the bottom. When access equals 1 and ascending is false, we are sorting by the column names in the descending order. So column C is now on the left and column A is now on the right. We can also sort by values. In this example, we sort the data frame in ascending order based on the values of column B. Now the data time values are January 1st, 3rd, 4th, and 2nd. Sorting is not done in place, so the data frame is still the old one. If now we want to select a single column A, we can use string A as the index like this. The output includes both the data time and the associated A values. We can also select a sub-data frame using the location function and labels. This part defines the rows from January 2nd to January 4th, including both. This part defines the columns B and C. As a result, this data frame contains 3 rows and 2 columns. We can also select a sub-data frame using the index location function and the indexes. Remember, Python indexes always start from 0. This part defines the rows from first row to third row, but not including the third row. This part defines the columns, the 0th column and the 2nd column. As a result, this data frame contains 2 rows and 2 columns. Here I show the data frame df again. We can compare column A's elements with 0. This is an element-wise comparison. The result shows only this number is greater than 0. It's marked by true. All other values are less than 0, so these positions are filled with false. We can also use this comparison result as an index like this. This is called Boolean indexing. We show the rows where A's value is positive. This comparison will check every element in the data frame df and find those that are greater than 0. They are marked by true. Other elements are marked by false. When we use this comparison as a Boolean index, it also returns elements that are greater than 0. Others will be blocked and their positions are filled with NaN. Here I show the data frame df2 again. This data frame with the label 2 means we select column 2. We further compare these elements to see if they are in this list that contains 3 strings. The isIn function works like a filter. T1 is in this list, so it's true. T2 is not in this list, so it's false. T3 is in this list, so it's true. Now we use this filter as the index to find the rows that meet this requirement. This is the result. We can also use these indexing and slicing techniques to assign new values to some of the numbers in a data frame. We still use this df data frame as an example. In this statement, we set all the elements in column B to 1. This is a new data frame. Then we set the element in the 0th row and the 2nd column to 100. This is the new data frame. In this statement, we set all the elements that are less than 0 in the data frame to their opposite number. In the new result, all the numbers are positive now. Occasionally, we may have to deal with missing data or empty cells in a data frame. As I mentioned before, missing data are denoted by NaN, which is short for not a number. In this example, we can set the elements in the 0th and 3rd rows and 4th column to NaN. This is the new data frame. The drop NA function with the dropping method how being equal to NA will show a new data frame by dropping the rows with any missing data. As a result, only the 2 rows in the middle are displayed. The fill NA function with value being -1 will display a new data frame by filling missing data with -1. This is the result. This is not done in place. The original data frame is still this df. The isNone function will check every element to see if it is none. In this output, only these 2 cells are true and all others are false. Okay, that was the basics of Pandas for data analysis. The course materials are available on YouTube and GitHub. You can watch the course videos in sequence. If you like this video, please subscribe and share. I'm Wang. Thanks for watching.